Hello.
Hello.
Hello, it's audible now. Hello. Everyone. Yes. No. It's okay. Yes, no. Okay. Okay. So, welcome to this session of Introduction to Elasticsearch. I am Manav Shrivastava and I am a software engineer and a web entrepreneur. So, let's begin. So, first of all, what is Elasticsearch? Elasticsearch is a document oriented database which is designed to store, retrieve, manage document oriented or semi structured data. When you use Elasticsearch, you store data in JSON document format and you query them for retrieval. Let me see comments. Okay, so Elasticsearch, as you know, it's used for search. It's an open source software and which is built on top of Lucene. Lucene is a Java library which is used for search. Its Elasticsearch is created by Sean Bannon. So it was created on 2010. So why we should use Elasticsearch? And is that scalable? So Elasticsearch can be scaled horizontally. If you want to increase our read capacity or write capacity, we can just increase the number of nodes in Elasticsearch. So let me go and give you what are the terminology which you are using on our Elasticsearch. As you are coming from RDBMS, or you're familiar with the relational database systems like MySQL, Oracle, Postgre, you're familiar with the terms like database, tables, rows. So on the same concept, on Elasticsearch, we have different name for the database. On RDBMS, we say it as database. On Elasticsearch, we called it index. We have table on RDBMS, we have type on Elasticsearch. Only the names are changed. We have row here, and here we have on Elasticsearch documents. The column is called field on Elasticsearch. The schema which we defined on RDMS is called mapping on Elasticsearch. And the queries which we do here on SQL, we have DSL, query DSL on Elasticsearch. So let's see what is indexing. As we have seen here, the database is called index here. So indexing, Elasticsearch is able to achieve fast search responses because instead of searching the text directly, it searches an index instead. This is like retrieving pages in a book related to keyword by scanning the index at the back of a book as opposed to searching every word of every page of the book. This type of index is called an inverted index because it inverts a page-centric data structure, page to words, to a keyword-centric data structure, words to pages. Elasticsearch uses Apache Lucene to create and manage this inverted index. So, Elasticsearch is distributed and highly available. Multiple servers, which we call nodes here, are running in a cluster, acting as a single service. Nodes in a cluster that store data or nodes that just help in speeding up search queries. We have a concept of sharding on Elasticsearch. The multiple indexes are sharded. Each shard can have a zero or more replicas. Replicas on different server, that is server pools for failover. One in the cluster goes down, there's no problem because we have a replication here. On sharding, we have two master or primary shard. If we want to read some data from the Elasticsearch, we can read the data from replica shard. So here is a diagram which shows how the shards and the API layer works. Inside the index, you can see we have multiple shards. At the top of that, we have API layer. A user can query through REST API and he gets the response back in JSON format. So as you have seen in previous diagram, we have shards, multiple shards in one index. Or when we create Elasticsearch server, we create a cluster. So let's see what is a cluster. A cluster is a collection of one or more servers that together holds entire data and give federated indexing and search capabilities across all servers. For relational databases, the node is DB instance. There can be n nodes with the same cluster name. So as you can understand, when we create a Elasticsearch server on any cloud, we create a cluster of that. Now we have near real time, that is NRT. Elasticsearch is a near real time search platform. There is a slide from the time you index a document until the time it becomes searchable. So as we have seen on our previous slide, we have index on Elasticsearch. So what exactly is an index? The index is a collection of documents that have similar characteristic. For example, we can have an index of customer data and another one for a product information. An index is identified by a unique name that refers to the index when performing indexing search, update and delete operation. In a single cluster, we can define as many indexes we want. Index is same as database schema in an RDBMS. Similar to a database or a schema, consider it a set of tables with some logical grouping. In Elasticsearch terms, index is same as database, type is same as tables, and document is same as row. Now we have another term on Elasticsearch, that is node. So let's see what is a node. A node is a single server that holds some data and participates on the cluster's indexing and query. A node can be configured to join a specific cluster by the particular cluster name. A single cluster can have as many nodes as we want. A node is one MySQL instance running per machine on different port, while in Elasticsearch, generally one Elasticsearch instance run per machine. Elasticsearch uses distributed computing, so having separate machines would help, as there would be more hardware resources. So, generally, a node is a single server that holds our data and it resides inside the cluster. Another term on Elasticsearch is shards. A shard is a subset of documents of an index. An index can be divided into many shards. Mapping type. Mapping type is same as database table in an RDBMS. Elasticsearch uses document definitions that act as tables. If you put index a document in Elasticsearch, you will notice that it automatically tries to determine the property types. This is like inserting a JSON blob in MySQL, and then MySQL determines the number of columns and column types as it creates the database table. Elasticsearch users have delightfully diverse use cases, ranging from appending tiny long line documents to indexing web scale collections of large documents and maximizing indexing throughput. So let's see how we can create an index on Elasticsearch. Index is like creating a table. So for that, we can do a curl operation or a RESTful API we can call. Suppose you have installed your Elasticsearch on your local system and you are running it, then you can call the Elasticsearch by the URL localhost colon 9200. So for creating a new index, if you see on screen, you are seeing we have a curl query of HTTP method put, and we have a URL localhost colon 9200 slash books. So what is the slash books? Slash books is our index name. Slash book, which we have on the middle, is the type of the index. Then slash 1 is the ID of that book. In the data, you can see we have title, authors, started, and pages. So in this query, we are going to insert a new book on our books index, which have a title of Elasticsearch, the definitive guide. So let's see how we can update this one. So for update, you can see we have another put query in which we just define the books index slash book type slash 1. 1 is the ID of the document which we inserted just now. So if you want to update the ID 1, we can, here we are changing the author's name. On previous slide, you can see on authors we have only Clinton, but we want to append a new name. Then we can do a put operation on the same ID. Here we are adding a new author. You can see the authors array. Now we have two values. Moving forward, if we want to delete the same entity, the same ID of book which we inserted by using HTTP delete method, or suppose if you want to get the value which we inserted on Elasticsearch on our books index, we can do it by calling a get operation. Let's move forward and see how we can do different kind of searches on Elasticsearch. So for doing search operation on Elasticsearch, we have to call HTTP get method. We are doing search on our books index and we are searching for a query Elasticsearch. When we run this query on our Elasticsearch, it will give us the following result, which you can see at the down. At bottom you can see we have the data in a JSON format which says that took 2 timeout false. and shards we have total 5, successful 5, failed 0. As you know, we had seen what is shard. A index is divided into multiple parts which are stored in shards. Shards are of two types. One is the master shard or the primary shard, another is the replica. So for this book index, you can see we have total 5 shards and all are running successfully. So on successful, you can see 5. Failed 0 means none of the shards are failed. Then we have hits object. In that you can see total equals to 1. When we queried for Elasticsearch, we get one relative result, and max score you can see how was the relevance of that search. If you see the hits array, you will see it will give you the index name. Underscore index means on which index the data is coming from. So we searched for books index, so that's why it's showing underscore index as books. And the type we have defined as book. ID we are searching for 1, as we have searched for a query Elasticsearch, so it's found on ID number 1. And what was the search relevance? The search relevance you can see here on score 0.07, and inside the source object you will see the exact data we are searching for. We have a title Elasticsearch, the definitive guide, author Clinton and Tong, started date and the pages. So the data we inserted on books index can be retrieved by such search operation. So let's move forward. On Elasticsearch, just like the SQL which we have on RDBMS side, we have query DSL on Elasticsearch. So here is the query. You can see we are doing a curl call, and of HTTP method get, we are calling books index of book type, and we are searching for the particular query. Inside the query, you can see we have filtered, then query, and we are doing a match query on text, that is to be or not to be. And we are defining cutoff frequency of 0.01. So it's a compound query. You can see here we have two conditions. One condition is that we are searching for a text query, and other we are searching for a range of price. On the below filter operation, you can see we have a range of price which defines greater than equal to, less than equal to. So the range should come inside GTE. GTE means greater than equal to 20.0 and less than equal to 15.0. So this will give us the respected result which we are searching for. So this example shows how we can make a compound query using query DSL in Elasticsearch. Now you know the basics. Let's see it live and how we can make our own Elasticsearch index and how we can do queries on Elasticsearch. For that, we have to go for some Elasticsearch hosting. Let me go to Google and search. So for Elasticsearch hosting, we have multiple platform where we can host our Elasticsearch. We can host our Elasticsearch on AWS, Google Cloud, DigitalOcean, and even on Elasticsearch, elastic.co. So for this demo, I am going for free hosting because as you know, the cloud computing on AWS or Google Cloud, we need to pay for using Elastic service. So for free Elastic hosting, we have multiple options here. One you can see we have Bonsai, Searchly, and elasticsearch.co. So for this demo, I'm going to Elasticsearch, elastic.co. That is the same company which created Elasticsearch. So if you go on this side, you will see we have a free trial. If you click on the free trial, then they have launch on Elastic Cloud. If we click on this, then it will give you some details that what are the services which you can use on their cloud platform. As if you want to create a new account on elastic.co, you can give your email here and you can start your free trial. As I have already created an account for demo, so I am just clicking on login. It will redirect you to cloud.elastic.co. Here you can see we have 14 days of trial. So for creating a new Elastic cluster, you can click on create deployment. Give your deployment a name, then select a cloud platform where you want to deploy your cloud. So Elasticsearch, the elastic.co uses AWS, Google Cloud Platform, and Azure for their cloud hosting. You can select the region, which version of Elasticsearch you want to use. As the latest version of Elasticsearch is 7.3.2. Then we have multiple options for optimizing. We have IO optimized, compute optimized, memory optimized. If you are familiar with the cloud computing, you know when we create any kind of instance, we choose them based on their performance, based on their characteristic. Some instances are good at IO operations, some instances are good for compute, and some are good for memory optimized. So based on that, as it's a database, so we should go for IO optimized. So select the IO optimized and click on create deployment. As I have already created, so I can show you, I have created a new testing cluster and I have deployed it on AWS. If I click this one, you can see the whole configuration of this cluster. You can define your own name here. This Elasticsearch cluster is deployed on AWS. You can see the health of the cluster, the version of Elasticsearch which you have deployed. I have deployed version 7.3.2, which is the latest one. Then the applications which I can use here. I have Elasticsearch, Cabana, APM, and here we have all our AWS instances detailed. So let me show you how we can create our own index and do CRUD operation on our index. So for that, Elasticsearch provide multiple tools, and one of the tool which we can use for Elasticsearch, that is Cabana. Cabana is like the user interface for Elasticsearch. Alright, so here you can see the Cabana dashboard. So Cabana is like an analysis and visual tool for Elasticsearch. If you are coming from RDBMS database, you may be familiar with the DB visualizer or phpMyAdmin. These are the database IDE. Using that, you can access your database. So, like same, we have Cabana on Elasticsearch. By using this one, we can create our own index. We can manage our Elasticsearch by using the tool Cabana. So if we click on Dev Tools, you can write your queries here on the left side, and the results you will see on the right side. So on the left side, suppose we want to see the state of our cluster. So for that, I've already written a query here. So I will show you how you can write your own query. So as I press G here, you can see it gives you auto completion feature. So I have selected get. Then you can see all the auto completion thing. So I want to see the cluster health. If I click on the play button, here you can see the details. The cluster name is this, status green means it's running okay, fine. Timeout false, number of nodes we have is 3, data nodes 2, active primary shards we have 15, active shards we have 30, relocating shards, initializing shards, unsigned, unassigned shards, delayed unassigned shards. All these details you can see here. Suppose we want to check the state of our cluster, then you can write cluster/state. Then I click on play button. Here you can see cluster state. Every cluster have its own unique ID, the version which it have, the nodes which we created inside that cluster, and all other related details. Suppose we want to see underscore cat slash indices question mark v. V is for verbose. We can also use pretty here. When I click this one, you will see that how many indexes we have on our Elasticsearch cluster. So you can see we have about 15 Elasticsearch indexes here. So let me tell you how we can create our own Elasticsearch index. Alright, so for creating a new index, I am giving the name of index as books. So for creating, we have to use put slash our index name. When I click on play, you will see it's telling acknowledged as true, shard acknowledged true, index books. This means that we have successfully created our new books index on our Elasticsearch cluster. So after creating our new books, we have a new books index here. Let me create a new index as authors. I have created a new index. Let's see, can we see it on our cluster? Yes, it's present at the last. You can see we have authors index. Here you can see we have docs count as 0, docs deleted 0, and how much size of that particular index. So after creating our own index, now we can insert a new data into our index. So for inserting a new data into our index, we can use post call slash books. Books is our index name slash book, that is our type. In that I am passing this data, title as a testing 1, author tester pages 1. When I click on this play button, you will see we have successfully created a new data into our Elasticsearch index. And if you want to see the result on books, we have get books slash underscore search. Inside that we can write query match all. When I play this one, as we have inserted one document on our Elasticsearch, so this data, as you can see, we found on our result. So whenever we query on Elasticsearch, we get our response in this format. It's a JSON format and it have multiple fields. Let me go through these fields one by one. Took 783 means how many milliseconds it took to retrieve the data from books index. Timeout false because it gave us the data in within the time limit. So timeout is false. Shard. So we have total one shard and successfully running shard is also one. We don't have any skipped or failed shards. So we have shards information here. Then we have hits. On Elasticsearch, the data which we get comes inside hits. So if you see on hits, we have total how many data we retrieved, that is one. Relation is the equal and maximum score. As Elasticsearch do the query based on inverted index, and in that it searches for the relevance of the document. So here we have full relevance 1.0. Suppose the data was less relevant, then it will give you like 0 point something. Now the data which we are interested in, you can see inside hits array. So as we queried on books index, you can see the index name is books, type book, ID, as I have not given any ID, so it's auto generated that ID. You can see on the left side, I have not given any ID, so the ID is auto generated by the Elasticsearch. Score, how much data was matched. So on this case, we have the data which we inserted on our Elasticsearch index. Moving further, let's see the mapping of our index. So what is mapping? So mapping is like schema definition which we do on traditional RDBMS system. Like we define our column and their data types. Same here we have on Elasticsearch as mapping. So we have three columns here, three fields here. Author data type is text. Fields, it's a keyword. And ignore above we have 256 pages. As you can see, it's a long because I have defined here one. So by default it takes long for storing the numeric values. So you can understand it's like a schema which we defined on RTMS. Suppose we want to update this inserted value. Suppose I want to change testing 1 into testing 2 or something. So I'm creating here a new document here of title testing 2. Let me run this query. On the first time when I run this query, we don't have any data with title as testing 2, and I have defined the ID as 2. Suppose I want to change this data, so I have to define the same index name, type name, and the ID name of the document which I want to update. Again, if I will click this one, so you can see here we have the result as updated. First time it was created, and the next time it's got updated. So let's check the data which we just inserted. So as Elasticsearch gives the data inside hits, we have hits array, and in that you can see, as I have not queried for any particular book title, I have searched for match all, and inside the hits array you can see we have both documents. One is testing 1 and one is testing 2. So let's create a new document here. You can see we have successfully created a new document inside books index. Type is like table, so inside book table or book type. ID is 3 and it's created. So let's see. When I run the match query here, you can see the new value which we inserted just now. Moving forward, how we can do some kind of text searching query on Elasticsearch. If I want to search for title testing 1, so I need to do a get query on books index. It's a search query, and inside the query I have to define I want to match a title with value as testing 1. So when we run this query, you see the total number of values we are getting 3, because all the titles are having testing. So based on testing, it's showing us all the values. Suppose I'm only searching for 2. Let's see what's the result. Now you can see when I searched for title 2, it just gave us one value. Which you can see here. So this is how we do query on Elasticsearch. And suppose if you want to delete the books index, then you just have to call delete and the index name. Suppose, let's see, we can see our index here. We have a books index on our cluster. So after deleting books, if I searched inside our cluster, you can see books is not present now. I hope this gave you a basic idea of how we can create, update, delete our index on Elasticsearch cluster. Let me go through the different features which you have on Cabana. Cabana is like IDE for Elasticsearch, just like we have DB Visualizer or Data Grip for accessing any kind of RDBMS database. So for testing, Cabana gives us sample data so we can see how we can use Cabana using our data. So I have already installed here three databases or sample database. One is for e-commerce orders, as I told you, Kibana is a visualization tool. So we can see our data. One tool which we have seen on Kibana is the dev tool, using which we can do query on our Elasticsearch cluster. Other feature of Elasticsearch is the visualization of data. Whatever the data which we have on our cluster, we can filter and visualize it. So here you can see we have a e-commerce sample data, and it shows how many transactions happened per day, what was the male, what was the gender ratio, average sales price, and you can create your own dashboard. And if you want to filter something, suppose you want to filter by city name, then it will ask you what kind of relation you want. Do you want the city name equals to some city? Okay, let's update it. So I have filtered here city name as New York, and the database has been changed. Now on New York City, you can see the transactions per day is 31. Gender ratio has been changed. Average sales count is changed. Total revenue you can see on New York. And the category, you can see which category. So as you have seen, is a sample data which I imported on our Kibana. If you go to Kibana homepage, you can see we have a link for add sample data. Elasticsearch provide multiple tools for visualization, monitoring, alerting. They have multiple tools which we can use for managing our project. Suppose we want to create a dashboard for our server or for our organization. So we can use the Canvas module for that. You can see the Canvas dashboard here, and I have three sample data. If I click on e-commerce revenue tracking, we already have a canvas for that. So here you can see we have a canvas for showing our data using graphics. So to represent our data using graphics, we can use Elasticsearch Canvas module. So these are the clip arts which we added here. You can customize these icons here and make your own canvas using the data which you have on your Elasticsearch. And this canvas will be a real-time representation of your data. You can just click on some icon. You can import your own image here. You can provide the data matrix here. It's really cool, as you can see. Any kind of amazing dashboard we can make using Canvas. You can just drag and drop it here and do whatever kind of customization you want. So moving further, on Elasticsearch, we have ELK stack on Elasticsearch. ELK stands for Elasticsearch, Logstash, and Cabana. As on this session, I'm not going into more details on Logstash. So this session was basically for understanding the basic concepts of Elasticsearch, how we can use the developer tool to create, modify our index. I will share this code on comments of the video. You can try this on your own cluster. I encourage you all to create a new account on elastic.co and try this feature on your Elasticsearch. So that's it for this session. We'll come back with another web session in which we will learn about ELK stack in more details. So till now, have a nice day. Thank you for joining the call. Bye bye.